For those of you who don't know me, my name is Daniel Devost. I'm the Director of Science Operations at the Canada, France, and Canadian resident astronomer. So this is a slide that I often talk about, put to other communities that don't know the telescope much, but you guys know it really well. We have a suite of 5 instruments plus graces, which has been talked about today. Very productive scientifically, as you could see, and I will try in this talk to show you what the user preferences are in terms of science and what the science productivity of each instrument are. But before I do that, I want to talk about what Andy talked about, just add one little thing to it. So this is the graph that he was talking about that he wanted to show you. So this is time, and this is a courtesy of Simon's software. It still works really well. This is time, and this is the 0 points here. So you can see that our slope at a little while ago was the slope shows the degradation, and this is not a fitted slope. This is just adjusted by eye, and you know we had a certain degradation here, and then at some point something happened, and I don't know what happened. I don't know what it is, and that was in 2017. The slope started to be worse, and the mirror started to degrade faster. Of course, here we didn't notice it because we were in our regular cycle of re-illuminization. But here in this period, it really showed up. And we started to worry about you know, what's happening to the mirror. And then Kevin Ho and his team came up with the genius idea, I have to say, of just drying the mirror. And it's a very simple system. It just, you know, you send dry air to the surface of the mirror at an angle. And lo and behold, it works. I mean, that's the U-band data. That's the worst degradation we get. If you look at this graph in the other bands, G, R, and I, you can barely see any degradation. So, you know, finally, yes, we can do more than 3 years between mirror re-illuminization, but then, you know, this happened. And Andy talked to you about it, so I won't spend much time here. Another thing on the technical side of things is that we're going to replace our phase 1 system, and that, you know, affects all of our users. We're shutting down North Star. It's become a really scary machine, to be honest, on the security-wise and on the running of it too. We had several problems. We never lost a proposal, but we were really close sometimes. So I won't talk much more than that about it, but starting the next semester, we're in development phase right now, but starting the next semester, we should have KLAU K1 ready. Some of you who use Espadon and Spirou are already familiar with our phase 2 system, K2. So this will be added to it, and it should have many improvements over North Star. So now to the PI science. So how do the PI use our telescope? Basically use our instruments. And this is basically the instrument demand. So this is the proposals that we receive from all of you guys every semester, split up by instrument. So you can see here in 16A, from 16A to the very last call, 21B, and these are here the color codes for each of the instruments. And you can see, you know, that Maycam's popular, but you have here Espadon that has always been really popular. And the thought was that when Spirou was going to come online, the Espadon users were going to migrate to it, or we'd have less Espadon users. But here you can see that the trend is really high resolution spectropolarimetry at CFHT. And I thought I'd sum these up together. And so this is the sum of all the demand, but from 19A, just to make it equal for Spirou, which is our last instrument that was commissioned and started in 2019A. And of course, Spirou, and this is PI only, this is not LP. So here, Spirou really popular, and Espadon still keeps going. People are demanding it, and there's a lot of good science coming out of it. And third here is MegaCam, and then WearCam and CITEL, which trail behind. And I think, you know, there's got to be a last instrument, but WearCam is an awesome instrument, and so is CITEL, as you could see in the first session. So basically, we're becoming a spectropolarimetric, high-resolution spectropolarimetry facility with a taste of high-resolution, wide field imaging. So now the PI science, the preferences of the PIs in terms of the science. So our former phase 1 system, North Star, was always asked the PI for the science category. So I'm not making this up. This comes from you guys. So you can see here, and that's for MegaCam. So here for MegaCam, I always like to see this trend. So here, this is IZ universe in red, and you can see that it climbed up in the 13, 14, and then went down and was replaced literally by solar system astronomy. And I'm certain that the LPs have something to do with that, because we did a lot of LPs with extragalactic science, and they have big teams. And Jean-Charles is going to talk to us about one of these programs. So for WearCam here, you have a hodgepodge of everything, no real trend. We had some time domain astronomy things, and the distinction between time domain astronomy and, you know, solar system and exoplanets is a little, you know, fuzzy, but I thought I'd add this category because of what's coming, LSST that's coming, and that this field is just going to explode. So also here it is for Espadon. So Espadon, of course, a lot of stars and exoplanets, star and stellar population, but also solar system and exoplanets, and some ISM astronomy and some low-Z universe, but it's extremely difficult with Espadon to do that. Graces, it's a piece of cake. When you put an 8 mirror on Espadon, an 8 meter mirror on Espadon really changes everything. It opens up this extragalactic science case, and you saw not for extragalactic, but there are extragalactic cases with graces. And here for CITEL, so, you know, ISM, low-Z universe, and some stars and stellar population. And here for Spirou, again, a lot of solar system and exoplanets, and some ISM, and these are mostly Wolf-Rayet stars that people study. So you kind of, the atmosphere is so extended that, you know, it's similar to studying the ISM. So our current LPs, so we have a round of LPs that we're finishing at this time in this semester. And before 22A, we completed Alessandro's program at 80%. So the SAC has mandated that at 80%, the programs are completed. And Laurie was talking about the signals, which we've passed 80%. So we're going to finish it also with a good completion. And we're really close with CFIS and DSLS. So all of them are really close to 80%. So that was a really good round of LPs. And I'm really happy about that. All of them got the majority of their data. Now for the new call, so Andy has touched on it a little bit. So the 22B, 24A proposal. So I'm not going to give proposal names and PI names and anything, but you can figure out just by looking at the graph. So this is, you know, nights requested, and here number of proposals in red. So Spirou had a lot of nights requested with one proposal. We won't name it. And then, but then MegaCam here, quite popular, 4 proposals with 200 hours requested. And Espadon and CITEL more or less at the same level, but no WearCam. Nobody has asked for WearCam time, which is sad again. All right, so that's my favorite graph. So that's our science throughput. So that's the number of papers over the years since the beginning. And this is last year, so we busted again at 230 papers. This is really impressive. And, you know, parts of it I think is due to our system, which is efficient at observing and giving you data of a decent quality that you can publish quickly, but also, our user community is extremely active. So here, I'm going to go quickly through that. When I count the papers, I divide them in 3 categories. Facility paper, which is you get a proposal, you publish the data. And then archival paper, you grab the data from an archive, you change it and you publish it. And then catalog paper, which has been really revving up in the last few years, where you take the data from a catalog that has been built with CFHT data. So you can see here the trends since 2013. And here the historical numbers of papers per instrument. Megacam dominates everywhere in the publications, basically. You can see also that WordCam and Espadon are more or less similar. And CETEL here is starting up, and Spirou also, of course, they're new instruments. It takes a little bit of time. And then here, I thought that was interesting to show you because of this facility one. You can see that Espadon facility papers are more or less similar to what we get from Megacam facility papers, which are, proposals that are put in, and the PI gets the data. But for archival and catalog, Megacam and WordCam, for archival, Espadon is doing pretty good, and I think some of it has to do with the polar-based data. I've seen a lot of papers on those recently. But then here, catalogs, I think it's WordCam and Megacam. It's just entirely dominant. So here's my punchline. En conclusion, 43 years of age. See, some of you say CFHT is old. I don't think she's old. I'd say she's in her prime. I'm done.
Thank you, Danielle. We have time for a couple of questions.
Sorry, it was just a follow-up on the catalog category. So basically, it's like follow-up observations.
It's well, the biggest catalog I can think of is the one the CFHT LS one. A lot of people are looking into the photometry data, building a paper from that, and then publishing that paper. There's the Supernova Legacy Survey catalog also, and there's the weak lensing catalog. These catalogs are extremely popular, and this is what I mean by that. People don't touch the data itself, don't touch the images. They just go to the catalog, extract whatever they want to extract from it.
So it might be old
publish.
catalogs.
Yeah.
It might be okay.
Oh, yeah.
Yes, Alicia.
One question, and probably this will make me very unpopular, but how much weight will have the small program with respect to the large program to be completed? So there are a lot of small programs that because of earthquake, COVID, they have had a lot of time but never got data.
We in the you saw what I did, what we did with the LP programs. With the PI programs, it's a little more complicated. There's more of them, and it's more sensitive to big problems that we may encounter. But we try to complete the highest priority ones, the A ones, at 80%. That's really our goal every semester, and we're getting more or less close to it. Then below that, the B type and the B priority and C priority, they're usually lower, sometimes they're higher, but 80% is really our benchmark in terms of completion for PI programs too, where you try to get to that. Does that answer your question?
I think so. Unfortunately, I think so.
Again, we have a fairly long discussion session at the very end where I guess it's something that can be discussed, the balance between PI and LP and things like this. Thank you, Danielle. So the next speaker will be Maribeth Lachak. Once the technology behaves, we'll be talking about cultivating CFHT's community